Hello everyone, in today's topic we are going to talk about some applications of graphs. This topic can be found in page 138 of your textbook. These are the terms to remember: graphs, applications, metric system, tie system, overtakes. Some applications of graphs. A graph accurately drawn on a suitable scale may often be used to find the results, although it is a rough, rather inexact calculation. It is particularly important that we should draw our diagrams on a sufficiently large scale and that we should be very careful in the choice of units, so whether your units is in the x-axis or in the y-axis. So let us have example number 1. Given that the units of length in the tie system, 4 sawks, are equal to the metric system 2 meters, express 6 sawks in meters and 2 meters in sawks. Let x be equal to your meters and let y be equal to your sawks. We all know that 4 sawks equals 2 meters. From here, in our equation, y equals 2x. So first, we are going to have our table of values. So it consists of your x and y. From here, when x equals 1, we are going to substitute x, or we are going to substitute 1 to x. So 2 times 1 equals 2. So when x is 1, y equals 2. And when x equals 2, substituting x to 2x, so 2 times 2 equals 4. So it's equal to 4. And when x equals 3, so we have 2 times 3 equals 6. Now that we have already our table of values, we are now ready to graph. So let y-axis be equal to your sawks, and in your x-axis be the meters. So from here, we are going to plot the points 1, 2. In plotting the points, your x comes first before your y, okay? And then 2, 4, 3, 6. Then we are going to connect the points. So from here, when y equals 6, x equals 3. So therefore, 6 sawks equals 3 meters. And from the graph, when x equals 2, y equals 4. So we can say that 2 meters equals 4 sawks. Let us have example number 2. At noon, A started to walk at 5 kilometers an hour. And at 1 p.m., B follows on a bicycle at 10 kilometers an hour. Let us find A when B overtakes A, and B when A is 5 kilometers behind B. So in here, let X be the hours, Y equals kilometers. And later on, along your x-axis, your 0 becomes 12 noon. Because it says there in the problem, at noon, A start to walk, okay? So in here, for the y-axis, equal to kilometers, and for the x-axis, it is hours. At 0, it is 12 hours, and then 1 will be 1 o'clock, 2 o'clock, and then 3 o'clock. And then 4 o'clock, and the rest is history, of course. Okay, so I will not extend anymore. From here, it says there at noon, A started to walk at 5 kilometers an hour. So he started at 12. So our initial distance and initial velocity, we have 0. And then 5 kilometers an hour, that is the speed. So after 1 hour, he is in 5 kilometers. Then since 5 kilometers an hour is the speed, we are going to add 5 in every hour. So at 2 o'clock, he is in 10 kilometers. And then at 3 o'clock, he is at 15 kilometers. So that is person A. Now we go to person B. It says here, at 1 p.m., B follows on a bicycle at 10 kilometers an hour. So he started at 1 p.m. here, okay? So zero distance and zero speed, okay? It says here the speed is 10 kilometers an hour. So every hour, we are going to add 10. So at 2 p.m., he is in 10 kilometers. And then at 3 p.m., we add 10 again. He is at 20 kilometers. Then let us connect. So that is the graph for person B. Now, it says there, find when B overtakes A. So where is that part that person B overtaking person A? So is at 2:10, correct? So at 2 o'clock, person B is starting to overtake person A. So we can conclude that B will overtake A at 2 o'clock p.m. Now, let's find when A is 5 kilometers behind B. As you can see, at 3 o'clock, person A is at 15 kilometers. And at 3 o'clock, person B is at 20 kilometers. So, in here, 20 minus 15 is 5. So, A is 5 kilometers behind B at 3 p.m. So, 20 minus 15 equals 5. Now, let's move on to example number 3. James was offered a job where he would be paid $15 per hour. He has an average daily expenditure of $50. He wants to know how many minimum hours he should work in a day so that he has some savings. In here, the word expenditure are your expenses, okay? Like food, transportation, and any other else that you are spending. So he is given $15 per hour. In here, we are going to determine the minimum, the lowest number of hours he should work so that he can save something. So from here, I already graph it for you. We just need to analyze the graph. So from the graph, when he is working 3 hours, he will be paid $45. So it's not enough for his expenses, correct? But working 4 hours, he will be paid 60. So 60 minus 50, he will gonna save something. So from here, the equation is y equals 15x because it says there 15 per hour for the salary. So if we are going to have 4 hours, so according to the graph, if he is working 4 hours, he will be getting 60. So according to our computation, working 4 hours, 15 times 4 equals 60. So $60. So if he will work 4 hours daily, then he can manage his earnings up to $60. Why I choose 4? Because if it's 3, it is 45. And 45 minus 50 is negative. While 60 minus the expenditure or expenses minus 50, at least he can earn $10, okay, in a day. So from here, we can say that James will need to work at least 4 hours a day to save some savings. Why I didn't choose 5? Because it says here minimum. The minimum hours. It is the least hours that he can work to save money. Okay? So this is the savings. So savings equals $10. And the minimum hours that he can work is 4 hours.